I'm Bernadette Cannon.
And I'm Norman Harris, and we are projected on the economic feasibility of geothermal heat pumps in New England. And Bernadette's going to give you a little bit what that's about.
All right, so a geothermal heat pump is a heat pump that uses stored energy from the warmth of the earth in order to heat a person's house. This isn't magma energy or anything like that. This is from the earth being heated in the sunlight. So about 50 to 60 feet down in the earth, it remains a constant temperature throughout the entire year. So you can use that difference of the difference of temperature between the ground and the air in order to heat your house effectively. So this will cycle liquid down into the ground in pipes and then move it back up to your house once it's been heated by the earth. The technology has been around for a while, but it's not very widely used because the upfront cost of digging these wells is usually pretty high.
Basically, what you have, there's three different types of systems you can have. You can have a closed-loop system, an open-loop system, and a standing column well. Basically, the closed-loop and the open-loop work similar ways. In New England, you're mostly going to want to use the closed-loop. It's more efficient. Standing column well is interesting because you can get basically two uses for your home in one. Standing column well will use a normal well for your host water and not only water but your heat. So they both work similar properties. As Bernadette said, you use the earth as the heat sink and you pump glycol water down into the earth at a cold temperature. The earth will heat it through heat transfer, and then it will be brought back up into the house where it goes through a heat pump. The heat pump will turn that into the energy used to heat your home, heat your water. Very efficient, and like she said, it's been around for a while, just not widely known because there is a high upfront for drilling. It's about $15 to $17 per foot, and typically the average home needs about 500 feet of borehole. So you can see that's a lot of pretty high cost to drill. Not only drilling, but you need to renovate your house if it's an existing home. So that, again, is like another $13,000 depending on what you use as your heating, whether you use forced hot air, forced hot water, or generate electric. Yeah. Typically, it's easy to convert to forced hot air because that's what the geothermal will use. Forced hot water is a little more difficult because the technology doesn't actually exist yet to be able to heat the water from a geothermal system enough to heat the water for forced hot water. So you usually have to convert the forced hot water to a forced hot air system. So again, more cost. But after about 4 years, though, with geothermal system, the price of electricity to heat your home is so much less than typically with even gas. It's less than natural gas, less than wood, less than coal, less than oil. It's so much less that you'll pay back the system in about 4 years. It's a very efficient system, very good for your home. I think Bernadette's going to give you a little bit more. There's more tax incentives.
Right, so because this technology is so good for the environment, the government has a couple tax incentives for it. There's a 30% federal tax income credit for the value of the system. Rhode Island has an income tax credit, and Massachusetts and Connecticut both have sales tax exemptions for the price of the system. So we didn't factor these in when we were calculating the payback period because that's a variable that won't apply to every state. But we looked at the different house sizes. We looked at different heat pumps with different coefficients of performance. That's how well it converts input energy into heat in order to come up with kind of an overall estimate for how long it will take to pay back the installation of the geothermal heat pump from oil.
We're pretty excited that we won. We entered this project kind of just going into it, hoping to see some other projects and see how we stack up against the IQPs, the MQPs.
And also Professors Rissmiller and Professor Savilonis, who are our GPS teachers for this term.
A lot of help through making this project and where we got to be today. So a lot of thanks.
We're really excited.
Yeah.